Let's take a look at this problem. We've got f of x is equal to x minus 3 to the 1/5 power plus 2. And want to find the critical number and open intervals which function is increasing or decreasing. So our first step is find our derivative. Well, this is the chain rule, specifically the general power rule. We've got parentheses to a power. If you got parentheses to a power, you'll take your power, put it out in front. What's inside the parentheses remains as is. And then you lower your power by 1. It's 1/5 minus 1. Now the derivative of 2 is 0, so that goes away. So then we got 1/5 times x minus 3. 1/5 minus 1 gives you negative 4/5. And we don't want any negative exponents. Now the 5 is already downstairs, so I'll leave it there. But this x minus 3 to the negative 4/5 I take down to the denominator, and it becomes x minus 3 to the positive 4/5. And that's our derivative. Now step 2. We want to find the critical numbers. And if you have a fraction, you set the top part equal to 0, and you set the bottom part equal to 0. I did that just to really emphasize what I just said. Set the top equal to 0, set the bottom equal to 0. But we know that 1 equals 0 doesn't do anything. There's no variable to solve for, so we can ignore that piece. Now over on this side, remember if you have parentheses to a power and a number out in front, you can just drop the power, you can drop the number out in front, and just set what's inside the parentheses equal to 0. So we'll set x minus 3 equal to 0, which then gives us x is equal to 3. Now here's our derivative. We want to plug that in. Now the key is, when you're plugging in a fraction on your calculator, if you have more than a single number or a single variable on top or bottom, you have to put parentheses around it. So when we plug this in, we want to put parentheses around the bottom part. Now even more than that, if you have an exponent that has more than a single number or a single variable in it, you want parentheses around that. So as we plug this in, we want parentheses around the 4/5. Lots of parentheses. There's actually a shortcut on this one, which I'll mention after I do it with the table. Well, let's see how to plug that in. Actually, let's do our table of intervals since I've started there. We only got one critical number, it's 3. Clear over here is negative infinity. Clear over here is positive infinity. Now I want to choose test cases. I want to choose something between negative infinity and 3. I don't know, 0. Something greater than 3, between 3 and positive infinity, like 4. Okay. Now let's plug this into our calculator. This is a little bit tricky, this one. Press y equals clear. Number up on top is a 1. It's 1 divided by, and I'll put a beginning parentheses for the denominator. That's this one right here. Then 5, and then beginning parentheses, x minus 3. Close parentheses on the x minus 3. And now we want an exponent, so we'll do a caret. And I'll do a beginning parentheses, 4 divided by 5. Now you don't have to have the closing parentheses at the very end. If you want to put them, that's fine, but if they're at the very end, you can drop all of them for TA3, TA4. Okay. So now we want to make sure our table setup is correct. So we do second window to go into table setup. You see where it says independent? Yours should say ask. If it doesn't, down arrow to that line, right arrow, put your flash and cursor on the ask and press enter 1 time. Then you exit out, do second mode, and we want to go into the table feature, so we'll do second graph. You may or may not have numbers there already. If you have numbers, you can press delete over and over until they're gone. And we only have we have 2 test cases, 0 and 4. So do 0, enter, 4, enter. Now notice both of them give me positive numbers. So this is increasing and this is increasing. So it's increasing from negative infinity to 3, and it's increasing from 3 to positive infinity. Where I get those from is these numbers across the top. This interval here is negative infinity to 3. This one is 3 to positive infinity. And that would be our answer. Okay, I mentioned a shortcut. You notice over here, 5 is positive, so we could ignore that. Here we got x minus 3 to a 4/5 power. Since the number up in the numerator, the 4, is even, that means it'll always be positive, which means I knew right away it was increasing everywhere. Anyway, that's our answer.